focused on aeroponics. We're here at SUNY Potsdam. Beautiful drive up through the Adirondacks, and things that you can see are starting to green up here behind me, which coming from the Adirondacks is great to see, but things are definitely green here at the Weiser Center. We are here with Professor Bodish. So Professor Bodish, thank you so much for having us. Can you just tell us a little bit about what we're seeing here? And
Absolutely. So this is the Weiser Center. You're in the greenhouse 2 of Weiser Center greenhouses. This was made possible by a donation from the Wagners. Bob Wagner was an alum, and he ended up having some extra money for his business, and he wanted to give the students of SUNY Potsdam the opportunity to have vocational experiences. And he himself, he and his wife both love gardening, and they really were interested in donating a greenhouse. The short story is we turned that idea of a greenhouse into something bigger. The Wagner Institute for Sustainability and Ecological Research, or the Weiser Center here in Potsdam. And we've expanded our vision towards sustainability and ecology because these two domains of knowledge are certainly important to our students, more important to the globe, and they're a way of teaching anything that you want to teach. So it's just like agriculture. If you talk sustainability or agriculture, you can match any of the standards that you have to teach to these domains of knowledge. So we've taken the Weiser Center in a bunch of different directions. They're all student-led. Everything you see today on the tour, good, bad, or different, is due to our students and their activities. Some of the initiatives we have something called the Healthy Planet Initiative, where students go into offices and departments and help take care of plants there, water them in some cases, but take care of pest issues, transplant them, prune them, whatever needs to be done. We have something called our IPM program, which is designed to teach students how to implement integrated pest management strategies. We've got the Campus Urban Farmer. Campus Urban Farmer uses the facilities of greenhouse to grow greens that go to campus dining facilities. We've got the Pet Plants Initiative, which was designed by a student in psychology to help people suffering from depression and anxiety by externalizing their care to a plant. Often they can start internalizing care to themselves. And probably our best initiative is the one you're taking part in today, which is our education, agriculture and education initiative. And that's actually how I met Katie, was through the tower guards that we're going to be talking about later. So the Weiser Center does a lot with our local community. We push into classrooms. We have events, educational events here, and we provide things on the internet to educate people about plants and keep them sort of focused on sustainability issues in the environment. So I'll take you through a quick tour. This greenhouse 2 it's really not in its normal state. We are in the pandemic, but I have 4 interns this semester, and they're utilizing these tables that have automatic watering systems. These are misters that you see here that broadcast water. They do that from the automatic valves, the lower ones, the middle one's the automatic valve. There are controllers for mist and irrigation that you can see that can be utilized. There you go. That's good. And so the students have a multitude of ways to control automatic water systems. Currently, all of what you see here are the pollinator plants. They're native species that we want to use in local gardens to promote natural pollinators. And these are going to go into our child care center here on campus. Unfortunately, during the pandemic, the communication was poor, and the garden we established last year was mowed by our physical plant members. So we have to go reestablish that garden. But it's one of those things that it's fulfilling to the students to start from seed and then finally into a garden. So even if they mow it next year, I think it's a fine thing. So we've branched off into different areas of agriculture. We've got beehives. these are actually, unfortunately, the remnants of beehives that didn't make it through last year. But we do have frames of honey that my new friend Jeremiah has been sort of drooling over. So we've got frames of honey here with some dead bees you can see on them still. And my sustainable ag course last year, we harvested honey in class, and everyone got to take a sample of fresh honey home. Students ate honey from the comb for the first time, etc. Another form of student involvement is through the clubs, and the clubs have, over the years, done a bunch of plant sales. So on these benches over here, we have myriad succulent plants, lots of aloe, variety of succulents on this table. Plants very, very easy to grow for students. And so the clubs have actually done plant sales and made 10 times more money with plant sales than they ever did with any of their other fundraising efforts. I think the example I use is they made $35 on a bake sale, and we made something like $475 on our last plant sale. So the students love to do the plant sales because we have events where our interns guide the members of the clubs through propagation and transplant. And then our interns grow the plants to the point where they're ready for sale. And then usually right at the end of the semester, when everyone's ready to go home, we have this plant sale. Or like this coming year, when we come back from the pandemic, we're planning a plant sale when students arrive so they can have a brand new baby succulent up in their room. Maybe they'll grow it for all 4 years while they're at college. So the students do everything in here. They learn how to prune, how to grow, proper watering, and they even learn how to control the greenhouses. Are there any questions so far?
No questions, but
some of the greenhouse facilities. There are shade curtains you're looking up at. We have fans occasionally that are blow air around. They're called horizontal airflow fans. Yep, right there. And those are very important for air movement. We have them off right now because it's very hard to hear it here when the fans are flowing. So we didn't want to ruin that for you.
so Ray,
The students
Andrea,
do everything, including change the control mechanisms for these greenhouses. They learn everything they need to do to actually run a greenhouse in some of our programs. So it's definitely an applied learning situation and something that's in the development stages because we only started in 2017 and then we shut down at the end of 2019. So we're looking forward to opening up after the pandemic. So in this greenhouse classes will use the space. Students for the plant sales, like I've said, if we're doing initiatives outside, like planting gardens, we start those in here. So this is kind of our production house. The next house we're going to go into is open to the public and the campus all the time.
So I think we have a couple of questions.
so well, there's a lot of enthusiasm for your beekeeping and wanting to try some of your great projects, but we do have 2 questions. So Andrea wants to know, are the succulents grown via cuttings?
Are the succulents from cuttings?
Yes, all the succulents you see here, well, not all, we have a few mother plants that were donated to us, sort of back here on in these big pots. These are our mother plants, and they're like 5 or 6 years old at this point. And so we'll go through and I'll show the students how to break the leaves off. If you break this leaf off here and just simply leave it for a short time, it'll start to grow roots out of the base here. And once the roots start growing out of the base, then you can just plant it in the soil and it'll grow. You can see in some examples here, the plants do that on their own. Sometimes you'll have a small, a leaf will drop and hit the soil and it'll start growing again. So succulents are great because they're easy to grow. Here's a perfect example of what I was just talking about. Here's a leaf that's fallen down and here's the new plant growing out of the leaf.
And Megan wants to know, where did you get your original stock of plants? They're looking for places to get plants on a tight budget.
Actually, most of our plants came from members of our community. Sales at Agway at the end of the year, when they're giving, you know, a plant like this away for say $1.50. I'll go in and purchase a few of the plants, but most of these came from the community or the campus itself through the Healthy Plant Initiative. So we've never really spent out for plants. We've just asked people for them. It's pretty surprising if you put the word out there, how many people are moving in their office or whatever, and they just want to unload plants. Other people are just generous and will actually give you cuttings from their own plants. So we've actually not really, I think we've spent a total of $50 over 2 years on plants. So, and where do we get them? Sometimes we get them online. There's no one place that I buy them from, but I do try to buy it from local greenhouses because I know the folks that run them.
And Andrea wants to know, since you're cloning plants, does your course cover plant genetics?
So one thing you need to know about the Weiser Center is we are applied learning, and so we're working with interns. And the course curriculum is something that's supposed to bring together what they've been doing in other courses. So we don't talk about plant genetics outside of the asexual versus sexual plant propagation, and talk about the evolutionary perspective of those. But no, we don't do a genetics course per se around this, but genetics is very important to those students that are going to move on in a career or toward agriculture. And so, if they haven't had genetics, I encourage them to do so. But we get a lot of environmental study students that actually take up the internships and help out here. So they often don't have the genetics background, so we have to give them a crash course in genetics when we get to things like cloning.
And that's all for now. Thanks, Ray.
Okay, so we'll go into greenhouse 1 here. Some of the things I do want to point out, we've got some interesting, we use a pressure washer here. We've had students who've taken, this is a fertilizer injector. So you run water through this end here, goes through a filter in the middle, and as it passes through, and it's in the on position, it sucks up fertilizer from a bucket here in through the injector and out through a hose, and then we water the plants with the fertilizer. You can use organic or commercial grades of fertilizer in that. We've got a sprayer, high pressure sprayer over here that the students learn how to operate. We usually use neem oil in here or something else called Sufoil X. That both of those are certified or useful for certified organic operations. So the students get trained on how to use these, and they use all of the technologies and materials that we have, equipment that we have in the greenhouse. And so here's greenhouse 1, and this is generally not configured this way. The excess of tropical plants you see around me is because when the pandemic hit, my normal crew of students that run around with a Healthy Plant Initiative and take care of these plants around campus, they were gone, obviously. It was just me taking care of the plants. So I endeavored to go out and grab the plants and bring them all into this one space in order to make it easy enough for me to care for them. But in here, this is normally open to the public. So people can come in here and just hang out. We have another initiative in terms of our social sustainability. We have yoga in the greenhouse here once a week, which has been pretty darn popular. We at one point, believe it or not, had 24 students in this space doing yoga in and amongst the plants. And like some of these really huge plants here have been on campus since I was here. I really probably shouldn't say this, but in 1983 to 1987 is when I attended Potsdam. And so the students have transplanted these plants and grown them out, and right now they're learning how to prune them. We've got a few health issues, and they're working through them. So I don't try to eradicate pests. I use biological controls with the students, and they learn to identify good pests and bad pests. So this is, from a horticultural standpoint, this might be considered a dirty greenhouse or a messy greenhouse, but we're teaching biology here, so it's important for us to have the pests so we can show exactly what they look like and how we would find them in the greenhouse setting. Any questions about that?
Do you mind showing us the card that you use to collect?
Thanks. Thanks, Katie. So part of our IPM initiative, Integrated Pest Management, we use these yellow sticky cards, and it's hard to see, but on the cards, there are little tiny insects occasionally. I think there's one like right here, into my pinky. And so I was just talking with one of my students, that's a thrips that's on there. And we've used something called Suff Oil X. It's basically canola oil, and it's what they call OMRI certified. So I believe OMRI is the Organic Materials Research Institute, and they certify that this is safe for organic use, the suffix oil. And my student commented after using the yellow sticky cards, he said, boy, that stuff works really well on thrips. Because he was monitoring the cards, we had a spray, he came back, and the buildup of pests on the cards stopped. And so it's great to see students learn by experience in that way. So we also, I'll show you a little bit more about that in a minute, but while we're in the greenhouse here, we're not using them right now because of the pandemic. We ran into some problems in terms of people being able to accept the type of food that we were producing. So, and I don't think I said this in the last section, I should have, but during the pandemic, we were able to hook up with a local restaurant and create food for people in food pantries. The food pantries were not willing to accept our live produce. And so we ended up going to a local restaurant who took the produce, made it into salads, brought the salad to the food pantry, and we're able to give them away that way. So let's talk about the tower gardens a little bit and how they work. You can see ours are sort of in the state of disrepair right now because we don't have any students. But the basic elements of it right here is the base and the lowest can. And inside this base, we have a pump. We've got a hose. In this particular design, we have a separate hose that goes out. Most of you won't have a design like this. It'll have one single hose going up here. So this pump moves water up and through this tube right here. So from that first, what we call a can in the industry, there are several of these cans. So they have holes at the bottom, you can see, and a center hole here where the water comes up through. So remember I showed you how the water came up through the tube in the bottom. And so now as it comes out of this tube, we start stacking the tower garden cans one on top of another like that. And as you can see, as we pile it up, that tube in the center gets connected. So at the very top, we have the final piece that's called the shower cap. And that fits in place at the top. And the water comes out of this hole, spreads over the top of these holes, and then falls through. And as it falls through, we can use this example over here. These baskets with rock wool in them are showered with water droplets. And so this is what separates hydroponics from aeroponics. Aeroponics are water droplets and not a constant stream of water, film of water like you'd have in thin layer hydroponics. So these baskets, you might have noticed, are not in the greatest of shape. And so some of the students get nervous because they're the ones who broke them. And as I tell them, it's really not broken if it still works and does the job. It's just a different shape, right? So these rock wool pieces that are used to grow the plants, this had a plant in it. We reuse these. Some growers say you shouldn't reuse them. I found that if you get rid of the plant material and you sterilize them chemically using a product called Zerotol, which is essentially peroxyacetic acid. It's a fancy way of saying peroxide and acetic acid in a very concentrated form. And that material is very good at wiping out viruses, spores, bacteria, fungi, all the things that could be pathogenic to the plant. So we'll reuse the rock wool several times. And I think, you know, grow a crop just as well in old rock wool as we do in brand new rock wool most of the time. I do want to say too that the towers themselves will help to cure some root disease. I'm familiar with a root disease called Pythium. It's a fungal disease of the root. And because of the aeroponics design and the water splashing over the top of lots and lots of oxygen, it's not a good place for Pythium. So Pythium leak will, which is the common name for the disease, can be cured basically using these towers. What normally happens is we have the campus urban farmer who is an intern who's usually gets 3 credits for cleaning, assembling, growing, harvesting, and documenting the harvest for the greens that go to our dining services at Pacey's. What's really cool is the dining services at Pacey's catering uses our greens, and when they do, they have a small bistro shop over at an eatery next door called Dexter's. And so when you go through their little bistro, if they use our greens, they'll say, oh, we have this arugula and mushroom and pecan salad using Wiser greens. So the students get this idea of, you know, understanding of marketing and a little bit of a sense of what it would be like to be in a farm to table operation right here on campus. Some of the extra food that we have that doesn't go to Pacey's actually goes to our campus food pantry or downtown to our neighborhood center where we'll donate it.
So we had a question. Can you use something other than, it said wool? So I don't know if the question is rock wool or wool wool. So can you first tell us a little bit about what rock wool is, and then is there another substrate that you could use?
So rock wool.
It is rock wool.
This is rock wool here, and it's basically an extruded mined product. So it's not unlike fiberglass in a way. These rocks are pushed through at high temperature and to form this like a fiberglass insulation almost. But it's an inert material that's easily formed, and it's highly water retentive once it gets water in it, which is one of the reasons we like using it. It isn't made out of, you know, compostable materials, but it does break down very, very fine. So you can grind it up and put it into a compost heap, and you really never would know it's there. If you throw it out whole hog, it'll be there years to come if you don't disturb it. But you can use other things. I believe Katie said in the last session that you have used cotton balls, anything that allow the roots to grow through and then get into the solution, because eventually here, that's exactly what they do. Roots will grow down and in, and you can see that in some of the cans that are left over here. Some of the first ones I showed you, see the remnant roots here at the bottom. I'm just those are all dried out, but as they go, and you can almost see here, I don't know if you've got enough light, but you can see the stains of the roots as they grew down and adhered to the sides of the cans. So you don't have to use rock wool. The problem is with soil. We've goofed around a little with soil. It's problematic because the filters and the pumps down there tend to clog very quickly, and it becomes very messy. So I recommend not using soil unless if you come up with a better way than I did it, maybe filter a little bit better with a bag or something, or maybe peat pots. I've never tried peat pots in a vertical grow system, but one of the reasons I do like the rock wool is it's easy for students to handle. It works really well with this system, and ultimately, because we get 3 or 4 crops out of them, I think they're pretty sustainable substrate. So the next thing is we have the lighting here. These lights are, I'll hop up this time. These lights are actually, you know, a good 10 feet off the ground. So if I come up here, I can kind of point it out, but the lights come right off. And the timer's right here. So you have tabs in and out, and you can set up your light timer for so many hours. What we tend to do here is do supplemental lighting to bring the light back up to close to 12 to 16 hours. And it's wonderful to teach students about how you can have too much of a good thing. So if you're teaching them about photosynthesis, they might think that, wow, the more light they have, the better. But I've set up experiments where we'll have constant light on some towers and intermittent light on others, and they'll see that the ones with constant light do poorly because they need the dark cycle to make carbohydrates from photosynthesis in the day. So there are a lot of things you can build into them. The tower gardens that we work with here are just what we work with on campus, but our educational programs have sought to gain grant funding, much like New York State, Ag in the Classroom. And we push curriculum, and I call them learning appliances, or growing, what do you call it? Educational appliances. That's my term for them. Because I'm not really convinced that the best solution for a garden per se, or that they're the way that humanity is going to feed itself. I don't think that that's really the goal of having these. These teach a lot about efficiency, about design, systems. All those things are built into the tower, grow towers or tower gardens in this case. Any questions?
No questions at the moment, Ray, but as we transition over to look at your panels and your microscopes you want to show us, can you talk a little bit? I get the question a lot. Is growing in a tower organic? And how does that play in your decision making as you grow on campus?
All right, so as far as I understand it, the U.S. National Organic Standards Board has just changed the rules so that tower gardens can be considered organic. As long as your seeds are organic and you have a source of certified nutrients, they could be organic. For me, someone who really is an organic farmer at home, I think it's very far away from what organic started being. I think of organic farming as an ecological style of farming, and I think that we can grow very clean plants here, but we're not really growing them in terms of the laws of ecology like we would do in organic farms. What I do like about the tower gardens is we're not using any pesticides on them. You know, the elements that we use to grow these are growing food all around the world right now in soil-based systems. So the organic farming is a kind of a slippery slope for me because I believe in it as a practitioner of organic farming, but like the commercial hat I wear as a commercial farmer as well, because my wife and I have we have commercial greenhouses as well. I understand the limits of growing organically. Having said that, on campus, moving forward, now that the standards have changed, we plan to market these as, you know, organically grown to the campus because we will have grown them to the standards that the U.S. National Organic Standards Board has laid out. We're not going to get certified because we don't have the money for that, but we are going to do an organic growing operation. Does that answer your question?
Yeah, I think that's great. Thank you, Ray.
Okay, so we're going to transition in the integrated pest management. I have to be honest, bugs are the thing that I love the most. I went to school for entomology. I worked with Colorado potato beetle and looked for sort of natural ways to control it. And so this little link area here is something, let me digress for a minute though. And, you know, the Weiser Center itself is really a community outreach organization from the campus to the community, specifically from the Department of Biology. So like a lot of the furniture, the signs you see here were either donated or created by local folks. This is actually box alder, which is not considered a really great wood by most people. But we take these throwaway pieces of wood and, you know, create beautiful pieces of art and furniture out of them. And our, you know, interns and we'll work with local members of the community to do these types of projects. But this link area, we call it that because it links the classroom to the greenhouses, has a cool little spot that we use for checking out our insects. So I've created a little rolling table that normally has a laptop on this side that I connect to a monitor, and then we also use a microscope, and we'll put a microscope camera right here in the ocular, and that'll feed back to the computer. And what that does is afford everybody having a shared experience and seeing the same thing at the same time. In your classrooms, if you're trying to use microscopes, you know it's very difficult to sort of point things out and show people things at the same time. So I've shared some links with Jeremiah and Katie that can guide you to some really nice technologies that will allow you to pretty affordably show insects and some interesting structures to the rest of your class, to your students, I should say. So here is something that, you know, when we built this facility, the administration kind of wanted to wall off. They wanted this to be hidden because we had electrical boxes and environmental controllers and things that most people would look at and say, "Oh, we don't want anybody touching that." And I have the opposite view. The students have such ownership here, and when they learn how to use this, they're the ones being the police and protecting it and making sure that people from the outside aren't monkeying with it. They're the ones coming in and running the mist timers right here, which is an hourly timer. It goes, feeds back into the greenhouses. The Rain Pro is a calendar timer, so we can water in 15 zones at all of these various tables that you see on the maps of the greenhouses here. These two units, whether it's mist or irrigation, can be controlled at each one of the tables. So the students learn how to program these. They learn not just that, at the end of what they're doing, they have to kind of control the greenhouse to be able to go into the panels, use the menus, and learn exactly how this works, from the source of electricity all the way down to the relay switches and communication cables that are needed for the entire system to work. So I think applied learning is about letting students take chances, make mistakes, and so you have to be willing to have yourself as part of the solution set to the mistakes that are made. So it doesn't always run smoothly, but if students make big mistakes, we solve those mistakes together, the problems that they created. So I don't know if we want to go upstairs now, or is there any other questions?
Yeah, we are just finishing up with our time with Ray and his tour. Are there any other burning questions? What questions do you have for Ray? Well, I can't say thank you enough to Ray. We're not done with him today. We love Ray for a lot of reasons in New York Ag in the classroom. And he's been a great partner to us. We love what he's doing at the Weiser Center. And he really, his teaching philosophies align so closely with ours and what we hope to inspire you all to continue doing with your students or start with your students. We are going to, Andrea has a great question. She wants to learn how to make one of the towers, and we will definitely get to that. So Jeremiah is going to transition at this point up to the classroom space in Ray's greenhouse area. And we are going to dig into some curricular connections, but we, like I said, not done with Ray. So we're going to come back to him, and we're actually going to go through the mechanics of how these towers are put together, pH nutrient solution. And then as we mentioned, we're going to follow up with Jeremiah about how you can build these towers with the tools that you are provided in your mailing. So hopefully you're able to pull out those tools, keep them close by. Any other thoughts or considerations as we transition over? That's a great question, Andrea, and don't worry, we won't lose it. Oh, Megan has a great question about putting water into the towers. So Ray will show you where he adds. There was a little rectangle at the very bottom piece and of that white top that sits on top of the basin where you start to build the cans one on top of each other. And so there is a little rectangle, and that's where you're going to be pulling water from to check pH, add nutrient solution, and you can add water in that rectangle also. Jeremiah, you just let me know when you're ready to go over there, and I'll pin your video. All right.
Well, I hope you all enjoyed the virtual field trip portion. It's pretty awesome to see and experience the Weiser Center as things start to open up. I know that Professor Bodish would be more than happy for you all to visit. So today we're going to take a look at what aeroponics is. We're going to put a challenge forth for you to participate, that you'll participate with our students. So when we're talking about the ponics, and I first want to define ponics. There are many types of growing methods, and I want to just quickly define those methods. So the first method that we're going to talk about is geoponics, and that would be that traditional farming in soil, and that's the important part with the geo. It's farming in soil. Professor Bodish did mention hydroponics. So hydroponics is the process of growing in water. You can see here's a great picture of a hydroponics setup. They have their net baskets, and this is a piece of styrofoam. And so what they do is, instead of having the inserts on the tower, the baskets are just hanging and the roots are in the water. The water level will be right here at the bottom of the styrofoam. Our next is aquaponics. So aquaponics is a big, it's becoming very popular right now. It's lumped in with aquaculture. So there's a process of farming off the seacoast, creating beds, clam beds, or large fish nets. But there's also growing within, if you don't have a large body of water, you can grow within tanks. So what happens with aquaponics is it involves aquatic life, and the aquatic life is part of the cycle. And so when you're looking for those nutrients are being produced by the waste that the aquatic animals are putting out. That water is cycled within the system into the plants. The plants pull those impurities out and use those as a fertilizer. And then that water is then purified and returned back into the aquatic life tank with any of the biodiversity that might fall off in those plants. We talked about pesticides and some ways to prevent pests. Also, any of that green matter. A lot of times you'll see things like tilapia are a very popular fish in aquaponics. So they will eat some of that plant matter and then convert that into fertilizer to go back into the system. And then today we're talking about aeroponics, and aeroponics is just growing in a nutrient-rich mist. So with our grow towers, Dr. Bodish discussed that dripping through. So there's that oxygenation of the water that you wouldn't have necessarily in hydroponics, where you'll have a circular pump and things will be circulated, but you're not having that droplet. There are nutrients that are added in hydroponics, aquaponics, and aeroponics. Adding those nutrients are very important. Whereas if you grow in those geoponics or in that natural solution, you have your soil, which is really holding that process. So before we go any further, does anybody have any questions? You feel free to unmute yourself or put a question in chat. So as you're applying this in your classroom, really to identify the needs of plants is a great way to insert some of this agricultural theory. So in your chat, what I want you to list some things. What do you think? What do living things need to grow and survive? So you can just put in chat and create a list. Water, space, food, air, gases, nutrients. CO2, vitamins, mineral, low light and dark, food, warmth, moisture. I think y'all captured all of them. When we throw this question out to our students, a lot of times we're going to hear sun, we're going to hear soil, we're going to hear air. So we can think about the things they need using the acronym LAWN. So we need light, air, water, nutrients. Two other things, those are a must, but when we think of space, we definitely need space to grow. And that's a great experiment in your classroom if you want to put a bunch of plants in one area without much space to grow and look at how they grow compared to plants that are properly spaced out. When we're thinking about forestry, you think about the amount of trees in a certain area and how if we have too many trees in one area, they're fighting over those nutrients, sunlight. So our soil or our forest is not as healthy. And temperature is very important. When we think about our seasons, when we have fall, we lose the pigments, or we have the pigments, and you're losing some of those enzymes and chemicals in our leaves that are showing those natural colors other than chlorophyll. And so we start to lose leaves, we go dormant for our deciduous trees and other plants. And then in the spring, we're starting to wake up. So temperature is extremely important also. A great experiment with that is the rate of growth with the different temperatures. So where's the soil? When we think about soil, soil is really like a bowl. It carries the things that plants need. So soil carries or holds plants in place, keeps them from being pushed around, blown, eroded. It holds water. And then it also holds nutrients. So when we're talking about aeroponics, hydroponics, and aquaponics, we can solve these three needs that soil would present. So when we think about growing in a bucket or a tub, we are holding that water. When we're adding those nutrients aren't being washed away into a watershed, but they're staying there in the bowl. And then those nutrients are then being cycled. So we have a continuous cycle. We do have to add water and nutrients, but we can really replace that soil. So here's our phenomena and the phenomena that you'll put forth as you participate in this lesson. This lesson can be found in our matrix that Katie will share here in a little bit. But according to the population projections, by 2050, we are going to have 10.5 billion humans. And so with that, what are some of the issues, and you can put that in chat, what are some of the issues that we face as far as humans? Food and space. Food production on less land. Excellent, Megan. Pollution. Depleted soils. Awesome. Those are all great. Those are all issues that we'll face as we look at a larger population on the globe. So with that, we are going to need to grow more with less. We're going to have more mouths to feed, less acreage. We're going to be taking up more land mass as people unless we start to populate Mars or the moon. There's some great things in NASA, but that's a completely different professional development. So we are going to need to figure out how we can do more with less. And that is our challenge for you. So our challenge for you is we have sent y'all a kit that can in a 5-gallon bucket. And actually we've sent you 3 5-gallon buckets, 2 kits, 2 water pumps, 2 sprinkler heads, some grow solution, a hole saw, and we are going to put you in groups, and we are going to challenge you to build out a solution to solving some of those issues that we face with the population using some of these tools that we have provided you. So your goal is you'll have 10 minutes. I'm going to share with you a design challenge handout. You're going to identify the problem. You're going to think about some solutions, and you're going to design a prototype or discuss a prototype with your group. We are going to need somebody who will be a reporter. So they are going to report out some of the ideas that you've had. And part of the engineering standards for the NGSS is that you need to create multiple solutions and then think through those solutions and what do you think would be the best solution to take to prototyping. So we're thinking of that brainstorming, and we can think through some of those prototype decisions that we'll make.
I've shared that link, Jeremiah.
Awesome. So in chat, you will notice that we put a link to that worksheet. These files are part of the lesson that will be shared out with you. So your group is looking to, we're looking at the engineering steps. So steps 1, 3, and 4. So we are going to put you into 6 groups. Does anybody have any questions before we break out into breakout rooms? So remember, you're thinking about the equipment we've sent you, and you're thinking of a solution, how to solve the phenomena with that growing population. Y'all listed some ideas, and some of the ideas were loss of soil, growing more with less. So you've listed some of those stressors. So you're going to create a solution for those stressors.
Andrea wants to know, are the materials that we provided the only materials they can use?
That's a great question, Andrea. So for my students, what I like to do is say yes and no. So when you're creating your initial solution, I want you to take what has been put on your table, and I want you to take those parts and you think through those parts. Once you've created that initial solution, I want you to take that the next step forward and say, Mr. Best, I think if I use this, I can ramp this up. I can ramp up the production. I can ramp up the efficiency. So when you're first designing your core prototype, I want you to use the equipment, or I'm challenging you to use the equipment that we provided you. And then as you've created that first initial and second solution, please, by all means, take it to the next step. And definitely think about light, air, water, nutrients, space, and temperature. What can I add to my prototype to increase that to help efficiency? Does that answer your question? Awesome. So we are going to start breaking y'all out. And if you have any questions about the worksheet, that link should be in your chat. And here in about 10 minutes, we're going to have people relay some of the solutions that each group were able to design.
You can go ahead and move to your rooms now. All right. Jeremiah, would you like me to put you into a room now?
I'll jump around.
Okay. Welcome back, everyone. Just give everyone another minute. He was explaining something to us and then we got cut off.
Yeah,
Oh,
so
no.
we're talking about the second part of the solution or the challenge was how can I make it more efficient? So the question was, I was given 5 baskets. Is that all I can use? And the answer is yes and no. So when you're working with students, we like to be able to put the Legos out on the table and see what they can create. As educators, we have that initial solution, and as the educated person in the situation, we have an initial solution in our mind, what we have been taught or trained. That might not be the only solution. So for my students, and really with the NGSS standards, we are wanting to go to that higher level thinking. So that higher level thinking is my first obstacle that I need to meet is to engineer out a bucket or a system, that aeroponic system I can grow in. I've been given these supplies, and the initial solution is yes, I can only use the supplies I have on the table. As an educator, I want my students to take it to the next step. And that's where I want them to think about, if I had more, how can I start to develop this prototype out? Now we're going to that deeper level thinking and understanding. I have a farm, I have a small plot. How can I develop that small plot? But then once I have that developed, increase my productivity. And that's how we work as adults. When we get into a solution, your first year of teaching, definitely are not where you are now. Or if you're in your first year of teaching, you're not where you were in the fall. And I want to say all of us with this virtual world, when I was in the classroom last March and last April, I am not where I am as a virtual teacher as I am now. So we take those next steps. So how can we take through agriculture those next steps? So you were given 5 baskets. The first solution is, yes, I got to use those 5 baskets, but then how can I use all those buckets and all those pumps? And that's where we're getting that higher level learning. So thank you so much for your time. I jumped into a lot of groups and there was some great discussion. So can I have somebody from group 6 share out some of your solutions that you were able to create?
Lori, were we room 6? I forgot to.
Well, we're going to share out 6 times.
I'll share out first then. So Lori and Teresa and I, we're kind of unboxing everything and kind of rediscovering it for the first time. We figured out, well, could we put the holes on top? And we also thought potentially, what would it look like if we were to use, say, the side? Would we be able to use the side as a place to grow from? And we started with a lot of questions, more so than answers, like what's the distance need to be with the bottom, how much nutrient to put in, how much water. So we have 8 of these buckets, or baskets. Can we use all 8, or should we, hold back? How much light can we put on there? And we figured out what the yellow washers were, so this stabilize those containers. So it's been good. It was quick, and I also I'll tell Katie as well. It is very much appreciated that you sent that drill bit, because my husband almost got out of drilling because he's like, I don't have the bit. And I'm like, yeah, I guess we don't have the bit. I'm like, well, I'll figure out what the bit is. And Lori was saying, she's like, it's in there. It got wrenches, and so it is much appreciated. These kits really make it not so scary to attempt. So I appreciate that. We appreciate that.
Awesome, thank you. Let's grow group 4.
We were thinking pretty much the same thing as what was just mentioned. Would you work with the top or lid and put the holes there versus on the side? And one of the things we wondered is, if you put them on the side, could you angle the basket slightly so that the root system would hang down without maybe impeding it. And then we talked about if we were going to have our students test the nutrient soil after it had been used in the mist, would we want to be able to collect it from the bottom? And would we then want a small opening towards the bottom of the bucket that would allow the students to get some of that liquid out with a pipette so that they could test it with some of those fancy little pH testing kits that we got. But really, we weren't entirely certain even how to move forward once we had those general ideas.
Awesome. And I think the process that you went through was exactly what we were looking for. Look at how you change that in just your conversation. Think about your students. If your students came and had the conversation that you just offered us and said, well, at first I thought about the tops, but then I started flipping it. And then I started about thinking of pulls. Think of that higher level thinking that they're going through to solve those solutions. And that's where those engineering standards, that's exactly where we want our students to go. Personally, one of my favorite things in the classroom is when things don't work out. We had a trout in the classroom program. I had somebody from BOCES come to do a 3D printing. I had just returned from paternal leave that day. 30 minutes from arriving, and everybody in the building wanted to help Mr. Best, and they overfed our trout, and I opened up the trout tank to a swirl of dead trout. It was one of the best learning opportunities ever in our history. We incorporated science, math. In 30 minutes, our students went and found the solution to what had happened. At first, it was a Hamlet type play, or Romeo and Juliet, where there was a poison involved in crop dusting and all kinds of. And as our students started to unpeel those through a chat that we threw up, this is an organic chat we had thrown up and said, okay, go to the town, and the Google chat, they found that solution. We also learned that we could take those fish and bury them in our school garden and fertilize them. And we learned about Native American indigenous people in 30 minutes. So I think that conversation that you just shared with us is exactly what the NGSS is looking to do. We don't want to be successful because in life, we're not successful in everything we do. We learn from our first year of teaching to our 5th year of teaching to our 20th year of teaching to our 40th year of teaching. So awesome. Thank you so much for sharing. How about group 1? I think Sanyal had a great solution she wanted to share with us. Her audio wasn't working, so we were joking in her group, but she did have a very intricate diagram. Yep, there it is. So she's going to send that to us, and we're going to have it patented. So does somebody else from the group want to share out from group 1 your solutions?
We didn't come up with too much other than that we've got 2 pumps and 2 buckets, but then the 3rd bucket doesn't have one. So if you could use the pumps that we do have to pump the water, then have it coming down into the 3rd bucket, then you can make that 3rd bucket useful at that point. And in the urban setting, if you could get your hands on more buckets, then with those 2 pumps, obviously you could increase your yield dramatically.
Awesome, I love it. Thank you. Group 2, did we hit group 2 yet? I'm looking for 5 and 6 next. So you're on deck. So group 2, I think there was a really elegant solution.
No, it really wasn't. It wasn't elegant at all. My neighbor built a rack system on the side of her house last year with buckets to grow pumpkins. It was an epic fail with pumpkins, but it worked out well for her other things that she grew. So I didn't know if you could just, have our tech kids build a rack system, because our kids are in ag and tech, build the rack system and put the buckets on there, and maybe do different. I don't know if there was like a cascading water thing that could go down. She didn't do that, but I thought that's what I would have maybe added, that cascading water. So you only water at the top and do like a drip system down. I'm not sure.
Awesome.
No, once they called me and they hung up. It was this 518853 number.
Don't answer them.
I did see if there was like a message for it.
So group 5.
We already went.
Oh, is it
That
group
was,
4
that was Danielle. We were group 5.
or group 3? So we've missed group 3. Anybody I haven't gotten to, let's.
Yeah, no, group 3. We said, since it's an urban environment and many times you live in an apartment, you don't have a yard. So we said, drawing. We had one where the bucket's hanging outside your window, and then you'd have holes in the top of the bucket. You'd have the plant. We would use the spray to take the water from the top and then spray it in here. So there's a pump. We said you'd connect the hose to the faucet to get fresh water. And then with the challenge of 3 buckets, that was that drip system. You connect 3 buckets. You hope you have nice neighbors below you. And then you use the pump from the bottom to bring the water to the top and then drip it down along the side.
Awesome. Thank you so much. I think that's a great solution. And usually in really using that side of the building, which is a hardscape, you can really kind of, some of that solar mass can be utilized for that temperature. So that's an awesome solution. Group 6, still looking for somebody from group 6.
Group 6 went.
So
Was that my group? I lost internet for a minute, but a lot of the ideas were shared, and we looked through the supplies and talked about putting holes on the side of the bucket and try and get it to mist as much as possible. I don't know if someone in my group already presented.
awesome. Thank you so much. Those are all great solutions. We're going to jump back in with Professor Bodish here in a couple seconds. I wanted to share one last slide. What you just participated in, you met practice 1, 2, 3, and 6 with the NGSS engineering. As you participate in this lesson with your students, you will meet all 8 of the NGSS engineering standards. That does not include your science, math, ELA, social studies standards that are incorporated in participating with this. We will share out these lessons to you. So as you can see, just in this quick activity, you're able to meet 4 of those 8 standards. As you build out and as you involve the plant, as the plant's experiments in the second part of the lesson, you're going to hit the rest of those standards. So as we're getting ready for Professor Bodish, Katie is going to share where you can find this lesson, as well as some of the opportunities that we have to engage with some of our grants.
Thanks, Jeremiah. We'll let him transition out so we can get into the mechanics of those tower gardens and get your burning questions answered. But I do want to share with you some resources, tools, grants, and where you can access these tools. So this is our homepage, this is our website, and you'll get a direct link to the lesson. But here is the most important thing. And if you've been with us, you've heard me talk about this quite a bit. This is our National Curriculum Matrix homepage. After our rotating photos, it's the first thing you can find. It's a keyword search tool that helps you access the best lessons from across the country. Every single lesson is vetted by a team of agricultural literacy specialists, and every single lesson is aligned to the Common Core learning standards. Most of these lessons, you can see I put Aeroponics in. This is where you'll find the lesson that Jeremiah led today. There are directly built in the next gen standards also, and the cross-cutting concepts that you are hitting by teaching this lesson. You can see there are 2 levels of this lesson. So this is the 6-8. The beauty about this tool is that you can search soil, you can search hydroponics, you could search water, dairy, vegetables, fruits, whatever it is you are interested in teaching about, and you can find through this tool. And there's a lot of things, but every single lesson looks exactly the same. It's going to have your grade level, your purpose, your time. It'll go in depth to the materials that you need. And then the best part about this is that all of your essential files are linked in and already done for you. So if the lesson references a PowerPoint slide, a presentation slide, that PowerPoint is already done. You can, of course, edit and change it as you need to, but any handouts that you need, the tool that you used earlier, that handout, is all included. The other beautiful part about every single one of these lessons that you're going to find on the matrix is that you don't have to be an expert in aeroponics or hydroponics to teach this to your students. There is just enough background information to make you feel confident to talk about these topics and subjects. Along with, you can see there is a how-to video, build these bucket systems that Jeremiah is going to walk you through a little bit later. So yes, we want our students to be able to manipulate those to their heart's content and their let their creativity flow. But you're going to have some background as to how all these pieces work and how they fit together. So you can see here are our cross-cutting standards, our three-dimensional learning proficiencies built out through each step of this lesson, built-in videos, images, models. You have the Arduino board connection if you'd like to use that as an optional programming, if you really want to get into the software programming and engineering concepts. We had some teachers in the last group who were super excited for that piece. And then, of course, any enriching activities. And the best part about the bottom of these lessons, it's like Amazon. You search for this. Katie, do you also like this? We thought you might like. So there are some other additional tools built in. Down here at the bottom, you can find your Common Core alignments. So if your administrator is walking by and wondering what is happening in your classroom, you can easily put their minds at ease, showing them what standards you're hitting. Now, the kits that you receive, the Aeroponic kits themselves, this is our Ag Classroom store. This is our resource store. Every kit that exists is already connected to a lesson. It doesn't exist, a kit doesn't exist if there isn't a lesson to go along with it. So here you can see the Aeroponic garden. These are the materials that are included, materials to gather, all these things we provided to you. So again, the video, the how-to video, and many of our tools have that already embedded in, so you know what you're doing. And then this is also searchable. So if you wanted an aquaponics kit for your classroom, that tool is also available on here. If you wanted a fish and a lettuce system, that's where you can find some of these really great tools. Before we transition back over to Ray, there's one last thing I wanted to show you on our website. So if you hover over grants, you're going to click the Grow With Us grant. We love this grant program. Normally, we offer 3 different types of indoor grow systems. This year, just because of the pandemic and we're off our regular cycles for grants, we are just offering a bundle of 3 tower gardens. So you can earn a bundle of 3 tower gardens. We invest about $60,000 into this grant program. So there are dozens of schools across New York State who could earn 3 tower gardens, dollies, the movable pieces so you can move them where you need to around your room, lights, and all the nutrient solution testing kits that you would need to be successful to grow food in your classroom. These applications are due May 15th, and we would love to see you apply for this opportunity. It's about a $3,200 value. So with that, I'm also always happy to take your questions. I'm right here in chat, but I'm going to pass it over to Jeremiah and Ray.
So we talked a little bit in the greenhouse about how these are assembled. I've actually shared some links with both Katie and Jeremiah. They can share them out with, you can figure out very easily just by Googling how to assemble a garden tower. So if you have questions about that, you can reference those. But really growing the garden tower and setting it up is a lot about the water, the nutrients that go in there, the pH of those nutrients. But I want to talk a little about the pedagogy of the towers, or using this agriculture across the different levels of education. And so, you know, one thing that I've had where we pushed into classrooms and brought tower gardens into the curriculum, or any agricultural stuff into the curriculum, I'll sometimes hear folks who say, well, you know, the curriculum's really, you know, based around 3rd graders or 5th graders, and I really can't use that in my high school classroom. And so what I'm doing is I'm going to institution of higher education. So I take on that challenge and say, okay, I'll take a third grader curriculum. I'll look at next generation science standards. Then I'll look at the standards that we have for our program here at SUNY Potsdam. And then I have to make the jump. I have to find the transfer, right? So what I love about science is we can start with the simplest things and talk to a kindergartner about this. Then we can talk to the master's and PhD students also about what's happening in here and go to those different levels. So let's talk about a little deeper level of biology and chemistry and talk some basics here that could be extrapolated right up to, let's say, PhD physics for the movement of water if you wanted to. When you start with a class, one of the things to get them involved is what they're going to actually put in the tower. So getting that conversation going about what they have and why. So we've got cut and come again zinnias down here, which are not edible, but somebody wanted to grow a flower in there. We've got parsley growing. In our other tower here, we've got cilantro and lettuce and cucumbers. So we've even got a little cucumber right down here already starting. So right here, we're talking about some advanced plant anatomy that I can talk about. We can talk about how every fruit comes from a flower. And you'd actually be surprised to find out a lot of college age students don't know that fruit comes from flower. And they always thought a cucumber was a vegetable, when in reality, it's a fruit. So there's a lot we can discuss, but I think student choice to get started with this is really important. What they want to plant is what should be planted in your towers or in your ponics system, whatever it is. The tower gardens come with sort of prefab minerals, and they're mixed into the reservoir that we were talking about before. And we've got minerals solutions A and B. So I'll start with A, and the three letters here on any fertilizer bag or fertilizer liquid that you buy in the store are nitrogen, phosphorus, and potassium, NPK. So this is a 2% nitrogen with 0 phosphorus and 0 potassium. The B solution, you'll notice, has a 013. So if you put them all together, the two solutions have all three numbers, 1% phosphorus and 3% potassium. However, when we mix these together, it's a problem. So in the first year I was teaching with the tower gardens, I had college students. I gave them these nutrient solutions and asked them to start a tower garden. Not a single one of them used the internet, which I welcomed them to do. And no one actually read the directions on the back. So they immediately ignored the directions that say put one solution at a time, right? You're not supposed to mix these. Well, they immediately took their graduated cylinder when they realized that you would need 20 mils for every gallon, and we know we have a 20-gallon reservoir. So they filled up to 400 with one, and then they filled up to 800 with the other, and they dumped it in the tower garden, and all of those salts precipitated out to the bottom, and we had basically no nutrients available for the plants. So that was a nice life lesson right there. But one of the things that's really important for these towers is not just whether or not you mix them. So if you put them in separately, they dilute, and then the molecules are far enough apart, the ions don't interact, and they don't precipitate. So that's why you put them in separately. But once you put them in, they will change the pH of this water, okay? So pH is very important for maintaining these tower gardens. And so the solution kit that I have right here is a simple vial, and then there's an indicator, pH indicator solution. And then we have a colorimetric pH test with numbers and colors. So I'm going to show you how I test. There are different ways to do it. Sometimes students will use small transfer pipettes. I tend to be a bit of a farmer at heart. So, I tell them just take the vial, and I want you to move it around in there a little bit. I'm swishing the water around because I want to get a sample that's representative of the whole. And then I'll simply pour that water out until I'm down to about 5 mils. See how close I can come this time. Not that bad. So it's a great time to do some skills and for Chem Lab. And we want to have that meniscus that is the bottom of the liquid right here. That's the meniscus. We want it to line up or nearly so with the 5 mil mark. All right, because of that surface tension on the water. Now, another nice thing, you can talk about surface tension, simple things like this. There's lots to talk about. So now, because we have 5 mils in there, we're going to add, according to the directions, 5 drops of the indicator solution. 1, 2, 3, 4, 5. And we're going to shake it around a little bit. And then we're going to set it down here for our colorimetrics. So I'm thinking it's a little darker than this one. It looks more like that in real color. It looks a little different on the screen, I'm noticing. So I'm going to say that this is roughly a 6.0 solution pH here. And remember, we're looking between 5, 5, and 6. But I want to mention about pH. Unlike a fish tank, if your pH changes, it can cause pretty immediate effects on the fish. For plants, you have a little bit of leeway. We've had as low as 4.8, as high as 7.5 pH. And for a limited amount of time, a few days, it's not a big deal. But pH is important because it's the solubility of the ions that makes it available to the plants. So a lot of our water up in the North Country is hard water. It has a lot of calcium in it. And so we have to make sure that that 5.5 to 6 pH is there so we can break those calcium molecules up, make things like iron available, calcium, nitrogen, phosphorus, and potassium, all of those. In some cases, when the pH is too low, it can actually cause detrimental effects. So we'll see some of those detrimental effects over here in this arugula plant. Early on, the lower leaves here, you can see have these whitish spots in here, and that is generally a deficiency of iron. And we know that the pH of these tanks were very, very low to begin with. Students didn't adjust it fast enough. So early on, we got some damage from basically from having too much iron available, and it causes issues with the plants. We've got some other issues here too. These are specks of a different kind. These are likely from mites. Okay, so mites are very common in the greenhouse. And the way we sample to find out if they're mites is actually to reach underneath the leaf here and then roll our fingers around a little bit. And if you feel a sandiness, that's because you've got mites there. So I didn't feel any sandiness on that one. It could have been mite damage from before, or it could be dead wrong about what's actually attacking these plants. So the problems you can have with the plants should be the problems that your students try to solve. I've had so many students come up to me and ask me, what is it? And I'll say, well, I'm not sure. How do you think we should find out? What's the first step that we should maybe take in solving this problem? So I think that the idea behind applied learning from my perspective, and it was interesting listening to Jeremiah talk about his perspective of it and having students of a different age. It doesn't matter. It doesn't matter if you're a third grader, a 30-year-old, or a 90-year-old. Humans learn the same way. And so the transferability of the issues that we discover through using an appliance like this educational appliance, to discover agriculture and ask those questions about, well, how are we going to feed a rapidly growing planet? How are we going to combat climate change? They can be discussed around these physical entities. I was just reading something out of how humans learn, right? And the truth is we all learn pretty much the same way through 5 channels. And the problem with our education to this point is that it's been limited to 2 channels, sight and sound, and mainly sound. And the article mentioned this thing that I thought was great. It's like, can you imagine our ancestors having a lecture about hunting and gathering versus going out and hunting and gathering? So your students are going to learn by doing much more than they're going to learn by you telling them about what is what. We tend to disengage very quickly as humans from that kind of an interaction. So my suggestion is short introductions to the subject, and then allow for investigation and time for discovery, communication and collaboration in groups. So remember the 4 C's, right? You've got creativity, collaboration, communication, and then the most important one, critical thinking. So if you can remember that those 4 C's are embedded into your next generation science standards and all the other things you're trying to teach in your classrooms, I think you're going to be a successful teacher, and more importantly, you're going to have successful students.
So Ray, we have a question, if that's okay.
Perfect.
So Andrea wanted to know, she asked this earlier and I wanted to save it for this section. She was asking about algae growth. She's getting a lot of algae growth in her tower. How could you combat that? What can we do with that?
I think the first question is, should we combat that? So a lot of us see something that isn't what we want, and we're worried about it. So we get algae growth all the time. If you look in here, we've got prodigious algae growing on top of this very, very healthy plant. So unless you think you can find a reason that the algae is causing you a problem, I wouldn't worry about it. But to answer your question, let me phrase it another way. Out in the main greenhouse, we don't like algae because the general public comes in and they go, ew, it's green, all over the tower, especially when they first start, if we get algae growth. So the way to solve that problem, answering the question, 10% clock solution on a rag is a great way to do it. Vinegar works fine because vinegar also takes the salts away as well as cleaning up the algae. But let's remind everybody, algae is edible.
So Sue has a great question. If you grow pollinator plants like flowers, can they be transferred outside or must they be sustained in the tower for all times?
So we've done some work of transplanting and we've had limited success. I think it depends on the age of the plant. I'm pretty confident if I pop this zinnia out right here now for you guys so you can see it, it's just starting to push fruits out of the bottom. And I'm darn confident that if I took this out and put it into a pot and just harden it off for a few days, because it's not quite ready to go out. Zinnias are a little tender. But if I harden it off for a few days in soil, I could grow this out into a full plant. So it does not need to stay in the tower. The places where we haven't had a lot of luck is where we've, say, harvested most of a lettuce plant, or we've taken a lot of leaves off this, or it's an older plant, and then we try to replant it and regrow the lettuce. We've had trouble.
And Sue wants to know, would you keep it in the rock wall or would you pull it out of the rock wall gently and place it in some soil?
I'd keep it in the rock wall. The last thing you want to do with roots is try that delicate operation of pulling. Roots like to be, touching things in terms of, well, I shouldn't say that because they are hanging down to the water. But in terms of a substrate, if you pull those roots out and then try to put them into another soil, that plant's going to fall all over. I heard Jeremiah talking about a soil is that anchor for a plant to keep it from going anywhere. I would suggest leaving it in the rock.
So Andrea is very intrigued by your shorter tower there, and she wants to know about the placement of your plants. Are you thoughtful about putting the cucumbers on the bottom because they're going to be a little bit heavier, as opposed to leaf plants on the top? What's your thinking there?
Well, it wasn't my thinking at all. It was completely my students' thinking. And what I asked were questions about, well, what do you know about how these plants grow? So when I asked that question and they saw, and they knew that cucumbers were wild and ranging and so forth, they made the decision for putting it down low. But you can imagine a different situation where if you had a plant up high, let's say that was growing out here with vines, and you had a shade tolerant plant and you could drape it around, you could probably grow lettuce in behind there, but it might be harder to, harvest and things and so forth. So if you're looking to use this as an educational tool, I think you just let it go in whatever direction it goes. And then when it goes kind of south, like the overfed trout that Jeremiah was talking about, if it goes south, you have those teaching moments to talk about it. let me digress for just a second. Right here, I see a problem that a student wrote me about, and we haven't solved it yet. But if you look carefully, the salts have built up on this old tower. We didn't clean the basket well enough. Back to something that Katie was talking about in the last session, that when you grow these towers, you've got to clean up after. This is all calcium salts. And the problem is when those calcium salts come in direct contact with the plant tissue, it kills the plant tissue. Now notice, this is surviving and it's growing. So we have an opportunity to correct the situation by simply diluting that area with a little squirter bottle and squirting that salt off there and cleaning it off. But when you're considering the formation of the tower, I mean, like Tower Gardens has all these suggestions and so forth. I think for education, that's the last thing I want to do. Like, yeah, put it in the top. Let's see what happens. And then they're like, you told us to put it in the top. No. I said, that was an idea and I'm down with it. You know, it's fun to see things go a little in different directions. And I just want to mention something. I'm seeing more students. I've been teaching for nearly 30 years here at this institution. And I have more students suffering from anxiety and depression before COVID than I ever dreamed possible. And it matches with the national statistics. One of the things I think is happening with our students is due to a lack of actual interaction with the physical world, and only interacting with things like games where you can just do over and start over. When they have something physical, they're timid. They don't want to break anything. They don't want to hurt anything. And so I want them to break something. I want them to goof up. I want them to make mistakes so they can learn that it's not the end of the world and it's nothing to be upset about. And there's no reason to be depressed or anxious about those sorts of things. I'm not saying one causes the other. I'm saying that their stress and anxiety that they bring into my classroom is something that is easily dispelled by letting them make the mistakes and just laughing them off and helping them correct it instead of, letting them sort of stew in the world of, oh gosh, I've made a mistake. It's the end of the world. I don't know what your experiences are in the lower grades, but I can't imagine it's much better now with COVID.
So Ray, we have a question. And so just so you know, if you have burning questions, now is your time to ask them. I'm going to ask Megan's question next, and then we definitely have time for probably 2 or so more questions. Megan wants to know, are there any plants that you found to be not successful in a grow tower?
Potatoes. They don't really make good potatoes because they grow underground, but the plant will grow fine in it. So if you're going to have root crops, I don't really recommend those. Obviously beets and carrots. So I have a couple of students that really want to try stuff like that, and I'm going to let them do it and see what happens. I would say stay to crops that can be harvested above the ground. But other than that, I don't know anything that can't grow in it yet.
Jim wants to know, are there any plants you've had to manually pollinate? Great question.
I do what?
Manually pollinate.
Well, I didn't manually pollinate these. I suspect my students monkeying around with them did the pollination. But yes, you've got to pollinate your cucumbers. So I'm noticing right now we have a lot of cucumbers that won't be cucumbers here because they didn't get pollinated. I don't know if you can get down there with the gimbal and see that. But here's an example of a whole bunch of unpollinated flowers that never turned into that cucumber. The cucumber I showed you earlier, I think by the students just monkeying around it, accidentally pollinated. So anything like a tomato or pepper, any of those things we've got to do.
Well, Ray, we cannot thank you enough for having us in your home today, in your Wiser Center home. We've been with you all day, and you are just a gem to have on our team, and we are always excited to partner with you. Ray and I have done multiple teacher trainings together, and he is always a pleasure to work with. We will include Ray's contact information if you would like to reach out to him to learn more about Wiser Center or pick his brain. So thank you so much for having us with you today and just being so willing to always partner on our projects.
Well, The feeling's mutual. Thank you guys, and it's a pleasure working with you all.
So at this time, we are going to move over and have Jeremiah, he's going to show you your kits and how the ins and outs of putting those kits together so you feel comfortable and confident using them in your classrooms. He is going to walk through each of the items. So if you have your kits close by, go ahead and pull those out if you haven't already in our last activity, because we'll touch and see how everything works together. Oh, Clayton has a great question, and we'll grab this with Ray. He wants to know about recipes for your own nutrient solution, a compost tea or something else. That's a great question. We'll ask Ray what he's done. Or if there's anybody else, I know there's some of you all who have great tower garden systems already in your classrooms.
I show the students how to mix that for the pH adjustment. You can buy nutrient solution packages and mix them up, and as long as you have good grade, mix them up.
So in your kit, we're going to quickly look at the equipment that you got in your kit. So the first thing that you should see, and I probably should put my camera so that you could see it. That would be quite important, is the hole saw. Although it looks intimidating, have no fear. So you will take this, and this can be used in any quarter-size drill or larger. So all you would do is unscrew your chuck. If you have a drill, and does anybody have a drill? Give me a thumbs up if anybody has a drill out there. All right. If you want to put your hole saw on, we're going to drill some holes. So, and all you do is tighten it down until you hear the click. Now, many of my students have never used a power tool before, and I was a 5th grade key. Well, I've taught almost all levels. So I've had high school students not use a drill or a power tool. This is a great tool to with. Again, we always talk about respecting it. With my 3-year-old, I teach daddy's tools are tools, not toys. So please don't use that maple hydrometer for an axe to split wood like that. So we always teach those concepts of respect and using that equipment. You should have also received a pump in this box. Cable. Now there is a method that you start these by soaking them in water before you plant in them. I have personally taken one of these straight out of the package, put seeds in them, and stuck the seed in the tower for an experiment, and I have germinated every time. I could be very lucky, but that was an experiment. We were successful. So when we talk about efficiency, we do soak them, but we also do sometimes put them straight into the tower. What you're going to want to do is put some kind of substrate over the top if you're going to soak them. When you have seeds, because these will dry out, you can buy a substrate like perlite, but what you can also do is just take a little rock wool and just press it over. It's really to keep water on top of it, to keep those seeds moist to germinate. Should have received a timer that you can use to have your time your pump. A lot of people, I have black ones, some of y'all have orange ones. This is to hold your seedlings. So what you would do is you put your stem through, and then you receive 8 baskets. So what you want to do is you want to start in your rock wool and just place your rock wool right in your basket. So we sent you 3 buckets. One of the buckets we are encouraging you to turn into your first potato garden for your school. This is a bucket for y'all to experiment with, for your students to experiment with. Again, I mentioned the power tools and not using power tools. This is a great chance to have that 1 or 2 brave students come up and use that drill. And when we were tapping maple trees, once our students saw that one student could tap a maple tree without losing an arm or being maimed or having major wounds, they all wanted to use the drill. So if everybody wants to grab their drill, you can see I have my first hole. You're going to want to hold your bucket stable, and you're just going to slowly let the drill do its work. It's pretty simple. You can see a lot of times I'll have that plastic piece left over and it'll pop straight off. So for mine, I used all my top portion for growing. And what I did is I used one of the rubber pieces and I drilled a hole on the side so that I can put my cord out the side. A little easier to carry, but that was my engineering when I was creating my bucket a few days ago. I figured it'd be easier to store and just kind of keep things compartmentalized. The way I did it is I just cut a groove around so that the side of the bucket is fitting and it's acting as a stopper. So the last thing we want to look at is our pump. This is a submersible pump, and these are made to be submerged. So you're going to want to fill your bucket. These are 5-gallon buckets. You can fill them up to the neck of the sprayer. You don't want to fill it over the sprayer, because if I fill it over the sprayer, it's not going to be able to spray. And the way that you attach your sprayer is your pump should just have the threaded end, and you righty-tighty. Now, if I wanted to change this and make a aeroponic drip system like a tower garden, all I would need to do, and you did have some elbows and other pieces, is to take a threaded hose and extend this portion of it. Also, if I want to change the spray a little bit, I can turn this nut. Don't be afraid if it falls off. You have not broken it. If you had turned it too much, it'll fall off. This brass fitting can fit right back on. Now, when you have your bucket created, you're going to want to keep this submersible pump submerged. So keep an eye on it. You probably start every week or so, you'll start to draw down as your plants get a little bit larger. So you want to make sure you have your eye on it, but you can add your nutrient solution straight to the bucket once you've added your water. I would add my water first and then my nutrient solution. We did send you a all-in-one nutrient solution, so there is no part A and part B. This is all the solution that you'll need. You just follow the instructions on the back. I think it's minimal that you need per gallon, not as much as with the Grow Tower. You also have the pH kit. So does anybody have any questions before we let y'all go about how to set it up? I think some of those solutions that y'all had, I really like the idea about turning it sideways, and you could have multiple grow areas. And I could put you can see just because when we're talking about cross-curricular learning, when I'm talking about surface area, area and volume for those elementary teachers, you can see that I'm going to have a lot more area. Now it's a circle, so that's going to take us to high school. But in theory, I have a lot more area if I turned it sideways than if I just used the top. So that is another great solution. So we have sent you 5 buckets. If you all have any questions about the setup or the lesson, please feel free to reach out to us.
So we
No
will,
question.
we are happy to take some additional questions, but we do want to get you out of here by 6. So we just have some announcements of things you need to know. First of all, in the next day or so, Jeremiah is going to send you an evaluation. Filling out the evaluation will do 2 things. Number 1, well, it'll do 3 things. Number 1, it'll give us some feedback about your learning experience today so we can continue to make these better. And you can give us ideas and topics of things you want to learn about with your students or dig in deeper with. The second thing it's going to do is give you your CTLE. If you want those 2 hours of CTLE that you just earned, we are happy to give those to you. And thirdly, by filling out that evaluation, you're going to be entered to win 1 of 3 grow lights. We have LED grow lights and we want to give them to you. So filling out that eval will put your name in a drawing to get those. So that's going to be coming out. We're going to be sending you the evaluation link. You're going to get the link to the lesson. Along with there, you can search all you want on the matrix. It'll be available for you to just explore all you want. And then finally, you're going to get a recording of today's session. So if you're worried about taking notes or want to go back and watch something or hear Ray talk about another concept, you'll have that at your fingertips.
Jeremiah, what was that product you said you sealed over the seeds?
So with the Grow Tower, if you receive the Grow Tower grant, they send a vermiculite, VERMIC light.
Yep.
But you can also use perlite, which is like little styrofoam balls. It's a inert grow medium.
Okay, thank you.
So with that, we are finished up for today, but Jeremiah and I will hang on for another few minutes. If you have some additional questions, and I bet Ray is still wandering around, we could grab him too. Thanks everyone for joining us.
Thank you for this. Thank you for teaching us these things. This is great.
We're glad to have you.
I think he's looking for bugs. He's wandering around. Thank you all. Have a great, and thank you for all you do for our students and parents and teachers, so, and other teachers and communities. Definitely, thank you.
I have a quick question, or maybe 2. So I have the rock wool, I soak it, I put the seeds in there. Do you let them sprout before you put them in the bucket? Okay, so let them sprout, get a good bit of sprout in there so that you can then put that, the little washer on there. So you need enough that it goes around there and seals it in, but it still gets light.
So I put the rock wool as soon as they've germinated, and I might have a 1/4 of an inch. I put that rock wool right into the Grow Tower. That you'll see in your buckets that you create, and if you look at a Grow Tower, it stays pretty moist in there. And that's really it's that aeroponic. So those seeds or those roots are gonna pull to the water, and the green is gonna pull to the light.
And with that little stopper piece, if that's what you're interested, if that's that little piece in your hand, you can cut that out a little bit more too, because it can just go, it doesn't need to go tight around the plant stem. It can go on the outside of the rock well, so it can kind of circle around the rock well, because it'll obviously grow and expand, so you can cut that a little bit.
The other question is just thinking about starting this year, a plant recommendation for something that's fun and maybe not edible, because everyone's so nervous about COVID in the classroom. Like I used to grow pea shoots and everyone just like eat in the classroom, and I think that's done for a little while. So I don't know, maybe like the zinnias or marigolds, something that might grow quick and everyone could take a little clipping or something. Any suggestions?
We are sending you, y'all should be receiving seed packets. I think you can get 1,500 seeds, which is a mixed lettuce blend. You know, one of the things I would do is look at possibly using it for compost. Talking about greens and browns, if people are afraid to eat it. But we have done wheatgrass. We currently have wheat growing in our tower just to grow it, see if we could grow wheat. We have pretty much taken everything minus vegetables that you could possibly grow and throwing it in there just to see, just because. And that's the fun part. So I think, you know, if you have some marigolds or other things like that that you want to start, give it a try. And definitely reach out and let us know, you know, because we can add it to our list, and the next PD we can say, oh yeah, Erica tried some marigolds and they're good.
And I do love the lettuce. And if we don't use the lettuce this year, we'll use it in the fall. And I'm quite certain people will be more confident to like be eating in the classroom at that point, maybe.
Right.
Even,
Well, we always have our teachers harvest, so, you know, have them harvest for that teacher salad.
even getting those wildflower blends, because it's a whole bunch of seeds mixed in, and how beautiful would your tower look just like blooming with that wildflower blend, and then being able to cut those and have your students bring those home. So anything like that, it would just beautify your classroom and get your kids excited, and they'll grow so fast with those lights and in that environment.
Or you could do something real fun and try mammoth sunflowers. That would be awesome.
Well, that's another good question about the lights. If we're using these bucket systems, just putting it in a sunny window, should it do pretty good?
So your bulbs in your classroom can act as grow lights. So you really need to do the red and blue spectrum of light for plants to grow. So any of like the LED lights, the fluorescent lights, they should all act as growing lights. They're not as efficient. You can put it next to a window, but you can grow with, I think they're 25s. I think if it's a 25, it will definitely work, and that's on the board. But any of your lights in the classroom should act as a grow light.
Okay, good. Thank you so much.
And the great thing about technology is that it's always improving and it's reducing the cost. So you can get on Amazon and get something relatively inexpensive for those tiny buckets, anywhere between $10 and $20, and it'll just speed things up.
So you're going to do a plant cell for marigolds, which you're going to then circle around to buy your grow lights. It's self-sufficient. I like it.
Thank you.
Any other questions? We're happy to answer. Clayton, you wanted, I think Ray was trying to answer Clayton's question. Were you able to relay some of that?
Yeah, so he was, I threw a question to a professor between two takes. So you got the very end because he was giving me the professor language. And told me, well, what do you think? Do you have a compost or do you have a mix? And he said he does not. He said there are blends, like powdered blends that you can buy that are less expensive because, you know, shipping and weight and things like that. And you should be able to do that. He said basically what you've gotten here is they've put together those nutrients, you know, calcium and other things, and then they've added water to them. So then they're charging you, they're upcycling it. So he said you can find those things out there. I have been thinking of, because we have a large composting program, making composting tea. I'm trying that, and I think that's, if you get to it before I get to it, please let me know.
Well, I just, you know, it would be another facet that you could do with the kids. And also depending on how big you got, if you did something else, you know, the cost would become a concern as well.
Most definitely. And something that we did is, number one, when you have kids involved, you let the kids sell the program. The kids are always talking. Kids are using that language. Kids are reaching out to the board. Social media, any kind of social media, anytime there's a board meeting, have the kids show it off. Because even though you might not be getting money from the district, there's a parent that sees it and says, hey, I want to fund that. That's definitely, you know, we put our kids first, and, you know, I had the benefit of teaching elementary, so when they're throwing out onomatopoeia kind of words and using it correctly, kids are like, "Oh, that's so awesome!" People want to support that. So I think the thing is, we always talk about think big, start small. So we always wanted to go to the moon, but then we needed to reverse engineer how we're going to get there. So I think by going with our grant and getting 3 towers, and then maybe having the kids hit up the teachers to buy a salad every Friday, and then you use that to then put in your nutrients. We do have an ag literacy grant that we usually offer every year. We're looking to offer that in the future, but that's another way to get some funds. It's up to a $1,200 grant. So there's another way to possibly get some of that support.
Yeah, we just built a new steam room here in Oxford.
Awesome.
And it's empty. So, like this would be a great beginning, but hopefully, a few other projects along the way would be pretty cool to have in here going in the elementary school.
Awesome. So you're down in Oxford, New York?
Yeah.
Well, we're looking at working with Cudex here in June.
Oh, yeah. They're amazing.
Yeah, we're gonna hopefully offer a virtual field trip, so to see their bees.
Yep, they're good people.
Yeah, I mean, reach out to them, say, hey, we want to get this going.
Yeah, great
Then,
idea.
Does Renee have a few towers in her classroom, or she doesn't?
She had some. I don't know right now. She had there was a couple available that were floating around over here. I haven't seen them this year, so I'm not sure if she has them down there in her room or where they might be.
Yeah. Oh, very good. Thanks for joining us, being with us today.
Yeah, thank you very much.
very welcome.
Hi, Caitlin. Did you have some questions, or are you just listening in? Oh.
All right, thank you. I've done it this year, the bees and the maple syrup. I've learned a ton, so I appreciate it. That's what I'm really looking forward to. We just got a local grant for a hydroponics unit. I bought a cheap one off of Amazon that was around $100. It doesn't come with lights or anything, but I put it together and we'll see what happens. So cross my fingers, and then maybe we'll add some grow towers and get things going for next year. Really a strong program. Do a few flowers this year.
You have 2 new buckets too.
Yeah, and now I got the buckets. Yeah, I'm really excited to get things moving. So thank you. I appreciate the inspiration.
And we do have our national conference coming up, and we do offer a scholarship. And a lot of these concepts will be shared and more with some resources. So definitely hit up that scholarship. I think it's like a $500 or $600. It's going to be virtual. Usually we'd ship you out to Iowa, where it's going to be this year. We'd pay for your travel and stay. This year, due to our restraints with Cornell, we can't travel outside the state. So we are offering, I think, like 50 scholarships or something like that to attend virtually. Next year,
I remember seeing that, but a lot comes through email. Maybe you could resend that with the evaluations, and I'll take
definitely do that. Next year, it's going to be here in New York. So,
oh, that's great.
Saratoga. So,
oh, I'm in Wilmington, up near Lake Placid, so that's really close.
Awesome.
Awesome. Well, I'll wave when I go by because I'll be going through Tupper on my way home.
Oh, nice. Where are you?
I'm in Inlet, New York.
Oh, okay. Yep.
On the other side of Racket, between Racket and Old Forge.
Yep. Oh, that's beautiful.
Awesome. Yeah, and I think actually our next PD is going to be from the Wild Center.
Oh, excellent. Nice.
We'll talk about pollinators and habitats.
Oh, excellent. All right. Well, have a good night. Thank you.
Awesome. Y'all too.
All right, Jeremiah. Well, thanks for everything. And we'll talk tomorrow. And you have safe travels home.
Thanks again, guys.
Thank you. All right, very good. We'll see you later.
Awesome.
I'm gonna get this downloading and hopefully we can get Sarah to edit and be out tomorrow.
Perfect. All right, have a great evening.
Thanks.
Did you hear,
Bye.
did you hear about what's going on down your neck of the way?
It's not good. I last heard there was 9 people shot.
Active shooter.
Yeah. I don't know if they've gotten him or not.
He's down, was he in Watertown?
Watertown, he held up a bank. And then he was on the loose in town is the last I heard. And then I just heard rumblings out the door that there were 9 people shot.
Hmm.
Crazy.
Well, you get home and you be safe.
Yeah, yeah. I'll see you later.
Yep, bye now.